As you saw last time, atoms of different elements have different atomic masses. Now this makes it very, very difficult for us to do calculations because we want to know how many particles there are, not just the mass when we do any chemistry. This is where the mole comes in. So our learning objectives for today are to be able to explain the terms amount of substance, mole and Avogadro constant, define and use the term mole and mass, carry out calculations involving masses using the amount of substance in moles, explain the terms empirical formula and molecular formula, and calculate the empirical formula and molecular formula. So the amount of substance. Chemists use a quantity called amount of substance as a way of counting atoms. The amount is measured in mole, given the unit mol, and it has the symbol N. 1 mole of a substance, any substance, contains 6.02 times 10 to the 23 atoms or particles. This number is called Avogadro's number. Right, so now I'd like you to have a quick go at these 3 questions for me. Just jot down the answers in your notes. A mole. Key definition of a mole, make sure you note this down. A mole is the amount of any substance containing as many particles as there are carbon atoms in exactly 12 grams of the carbon-12 isotope. So molar mass. Key definition again. Molar mass is the mass of 1 mole of a substance. It is equal to the relative formula mass in grams. So for example, iron has an relative atomic mass of 56. 1 mole of iron weighs 56 grams. So, questions. How many moles would 112 grams of iron? How much would 3 moles of carbon weigh? And how many particles are there in 20 grams of calcium? So, to calculate the number of moles, we have a really, really simple formula. Moles equals mass over molar mass. Really easy to remember that one. So, for example, how many moles are there in 48 grams of carbon? Well, moles is mass over molar mass. So, moles is 48 grams divided by 12, the molar mass of carbon. And so, moles equals 4 mole. Right, the empirical formula. This is something that you will have looked at in year 11. Using what we know about moles, we can find the ratio of atoms in a compound. We use empirical formula to represent giant substances such as sodium chloride, but we can also use it to help us work out the molecular formula. So, as an example, what is the empirical formula of a compound that contains 86% carbon and 14% hydrogen? Now, whenever presented with a problem like this, I want you to start with a table, just like this, depending on how many elements you have. So the first row of the table is going to be elements, and I'll fill in the elements there with carbon and hydrogen, because those are the elements given to me in the question. So the next row is going to be mass. Again, fill this in from the question. I don't care that it says percent, just fill in the number as if it was grams. So I've got 86 and 14. The next row down is going to be moles, and using our calculation for before, moles equals mass divided by the molar mass. And so we're going to have 86 divided by 12, and that gives me 7.16 moles of carbon. And then I'm going to have 14 divided by 1, and that gives me 14 moles of hydrogen. So then I want to find a ratio, because it said that empirical formula is the simplest ratio. So to do that, I'm going to divide all of that third row down by the smallest one I've got there. And in this case, it's 7.16. So I'm going to do 7.16 divided by 7.16 is 1. And then I'm going to do 14 divided by 7.16. And that equals 1.96. So, all I need to do now is write out my empirical formula. I've got my ratio of atoms. So the empirical formula is just the ratio of 1 carbon atom to 2 hydrogen atoms. So I've just rounded that number off. Now, once we've got the empirical formula, if we're given the relative formula mass as well, we can then calculate the molecular formula. So we can calculate the actual number of atoms in a molecule of that substance. So, using that same empirical formula we've got before, CH2, if you were told that the relative formula mass was 56, all we need to do is this. I'm going to work out the empirical mass, so that's the mass of one empirical unit. And so the mass of CH2 is going to be 12 plus 1 plus 1. And so that comes to 14. So now I'm going to work out the number of empirical units in my molecular formula. And so to do that, I'm going to do 56 divided by 14. So that tells me 4. I've got 4 empirical units in that molecule. And so then I know that I've got 4 lots of CH2. And so I've got C4H8. There's the molecular formula. Right, though, to summarise, a mole is the amount of any substance that contains 6.02 times 10 to the 23 particles. The molar mass of a substance is equal to its relative formula mass in grams. Given the mass of a substance, we can calculate the number of moles using the equation. Given the percentage composition or mass composition, we can calculate the empirical formula of a compound. And given the relative formula mass of a substance, we can calculate the molecular formula.